So, that worked pretty well. Good morning. I am Ellen Hannock. I'm a senior fellow at the Public Policy Institute of California. I lead our work on water policy, and I'm just so delighted to be able to welcome you here today. Thanks so much for coming and for joining us for this kind of half-day powwow on what to do, how to get better at managing drought. As I'm sure all of you know, we've been in the midst of a serious drought. Last year was especially dry, but it was the third in a row of dry years, and it's quite possible that the year that we're entering is going to be dry as well. Droughts cause a lot of stress for California's water systems, for our economy, and for our environment, and it's also something droughts are something we have to be prepared for because they are not the kind of thing that just happen now and then. They're a regular feature of our climate. So droughts provide a lot of challenges, but also opportunities for us to look at how to get better at managing that challenge. And before I give you a little bit of an overview of the day, I just want to start with an apology, which is that I was sure it was going to be raining today. Last year, pretty much the only rain we got were on days when there were either hearings or meetings about the drought, and we haven't even managed to do that for you. So if we've broken that pattern, I'm hoping that at least maybe we can look ahead to some more rain in the coming year, and that we've broken the pattern of the ridge as well. So now on to kind of telling you a little bit about the day. First, I want to start by thanking the California Water Foundation, which has been our partner in organizing this and which has generously sponsored the event. It's been wonderful to work with them on this, and as many of you know, they've been an important leader in California water policy. There are a number of the folks here today from the Water Foundation, so please say hi and say thanks to them for this. So, in a lot of ways, this drought has been very stressful already, but it's also created a moment of opportunity for California water policy. PPIC does regular public opinion surveys, and it's been just incredible to see how much public concern and attention there is on water policy, on the drought, but on water more generally this year. It was also a year with a lot of action at the state and local level, both by agencies, but also by the legislature and by the public. The legislature put a new water bond on the ballot, and the public overwhelmingly passed it in November. There was also major legislation enacted on groundwater reform, and a number of other things where the legislature and the administration took action. But I would say that a lot of work still lies ahead. And, thinking about this, we have not only to think about getting through this drought, but also what California is facing coming down the pike with continued population growth, with a changing climate, and also with the need to deal with aging infrastructure and some real environmental challenges in our aquatic ecosystems. We really need to think about developing meaningful, lasting, forward-looking policies for California water. And we at PPIC have been aiming to be engaged in this process by providing objective, nonpartisan information and analysis to bear on California water policy. We're hoping to ramp up our efforts in the year to come to help to meet this historic opportunity in California water. So now, quick overview of the day. We've got a really exciting agenda, packed schedule. We're going to start with a couple of keynote addresses. The first is going to be from our state climatologist, who's going to situate the drought for you in the context of the historical record and also what we're seeing from climate models about what this might be in terms of how it looks in relation to potential future droughts. Then we're going to be hearing from a leader from Australia who's come over here, especially for this event, somebody who's been involved very much in dealing in the trenches with the mega drought that Australia went through not that long ago. And then after these two keynotes, we're going to have a bipartisan panel of legislators from the California State Legislature to talk to us about legislative priorities. Then we're going to have 3 panel discussions that are going to touch on different aspects of drought management. And each of these is going to be panels of state and local leaders, with one of my research colleagues kicking off the panel with some introductory remarks, a bit of a recap on what, from their perspective, happened this past year and some provocative proposals that they're going to hope the panel will respond to. Now, I'm going to be your MC, and I'm a little bit nervous about this because it's Hollywood Awards time, and it's very hard to live up to those standards, but so please be patient with me. But I'm going to be your MC, and I'm going to moderate those last 3 panels. Now, all 4 of the panels are going to have some time for audience Q&A, so we're really looking forward to having some time to interact with you in that way, and there'll be mics ready to be passed around. This is being webcast live. Welcome to the folks that are tuning in from the web. Those of you tuning in from the web, if you'd like to provide comments or questions, please use the hashtag #PPICWater, and we'll try to incorporate your remarks into the discussion. Okay, finally, just a little housekeeping, and then we're going to kick off. We're going to have a couple of short breaks during the day. The restrooms are upstairs and in this direction, to my left, your right. And coffee and tea are going to be available outside all day. And then the last panel is going to be, we're going to serve lunch during that last panel. So we're going to need you to get back quickly. I'll give you another reminder of that. In your packets, you'll find a few things. You'll have the agenda and speaker bios. You also have a few really useful fact sheets on the drought, on water use, and on groundwater in California. And you will also find an evaluation form. And we'd ask you, please, before you leave today, if you could fill that out. That's so helpful to us in helping us to get feedback on how to improve our events in the future. So with that, I will say, get ready for the action. And I'm going to introduce our first speaker, Michael Anderson, California state climatologist. He's with the Department of Water Resources and has got extensive experience in climate modeling and monitoring. And I'm going to pass it to you, Mike. You're going to take it away. Thank you.
All righty, good morning, everybody. So, you see in your agenda, they gave me the title is Today's Drought, a Harbinger of the Future, and I decided to talk to you now about climate, drought, and change, because things are changing. All righty, so here's what we're going to go through in 20 minutes, the best of my ability. First off, the rules. The rules of what? Well, this is the rules of how water shows up in California to the best that we know of so far, and understanding that while we're learning about them, they're changing. And we'll get to what's happening now and talk about signs of change. So here's first and foremost what we really need to know. California's climate and weather really depends heavily on its topography. And the shape of California, its location on the planet, are fundamental pieces to how and why we get what we get. And you can see that from, see if we can do this right. Hopefully, you've got deserts in the southeast that are barrier mountains that keep the moisture. Sierra Nevada wall, wet and moist further north. All right, so we're going to focus on this area for a lot of the talk. This is the Sacramento River Basin. On the top chart is the department's 8-station index, which is 8 rain gauges that are average. They have a nice average of 50 inches in a year, and this is the monthly distribution on top. And we see that in December, January, and February, half the annual precip falls. So you have a 90-day window where you get half the annual precip. That, in some ways, it's nice and tidy, get everything and make use of it, but it also makes it all or nothing to some degree. Here's the Sacramento River flow. Notice the peak doesn't line up. And part of that is because some of that precip falls as snow and then melts. The numbers here, again, when we talk about averages, and before long I'll have you convinced that averages don't really matter anymore. It's about 18 million acre feet. And here we go for why averages don't mean a whole lot. This is a fantastic chart put together by Mike Dettinger down at Scripps and USGS. And what he did was he took all the cooperative observer rain gauge sites, and he took the standard deviation of the year-to-year precip, divided it by the mean so you could compare it, and everywhere you see a little pink dot, one year looks an awful lot like the next. Notice where Washington, D.C. is. That's really important, where a lot of the federal programs are. Compare that to what's going on in California. We win. We have more variability year to year than anywhere else in the country. That makes things both good and bad, and we'll see that in a little bit too. But that's the first step to remember. We are the most variable place. Now here's what's more fun. I told you that it was 90 days to get half your annual precip. This is another one just to get you even more antsy. Those are the number of days of precip it takes to actually get that 50%. And you'll notice those numbers are down around 15. Okay, so we have 90 days to get 15 days. So that means when we get rain, it's going to come not just evenly, a little bit day to day, but it comes in punches. And that's another aspect that we're going to look at. And this is part of the puzzle of why. This is how to make rain happen in California. Just a few moving pieces and parts with the Pacific Ocean, and this doesn't even describe what's going on in the Atlantic that may have a role in the process as well. But what we have in the tropics, we have a lot going on. We have all these bright, fancy Jerry Garcia type colors. That's water vapor. Where you see the bright colors, that means there's a lot of it in the intertropical convergence zone. Now, coming out of the tropics, you see these little filaments. Those are called atmospheric rivers. They're really important. 90% of the equator to pole transport of water vapor happens in those filaments. Now, remember, I said rainfall happens in punches to us. Well, here we have storms that come across, and in the wintertime, that storm tracks south, comes back up in the spring. Again, that kind of fits our nice 90-day window where that might line up. So we have to have that coming south. That's influenced by things going on in the pole and in the tropics. And we have these fun-loving words and cryptic items like ENSO, the El Niño Southern Oscillation, and MJO, tropical convection, the Madden-Julian Oscillation. And these are different processes in the tropics that can really kick the atmosphere. But they're not the only things going on. We also have polar processes, and you'll notice polar processes is just in white. And that's because the poles are changing quickly, and we don't know a whole lot about it. Now, that's kind of fun. You don't know a whole about something that's changing rather rapidly and could have significant impacts on what's going to happen to you. Anyway, all that has to line up. When it lines up right, boom, we get a flood. When it kind of lines up, we get some good storms, and when it doesn't line up, we don't. And that's what it says. The size of the atmospheric river results from the alignment of key processes. The absence of these means we're dry. And there's some pretty interesting proof that happened just last year from Dettinger and Kayan. And we were trying to kick around this notion. If you stare at annual time series enough, you see this kind of wiggly thing on a decadal scale that you swear to yourself something's going on there. You ought to be able to figure that out. Nothing really stands out, though, in the physical world that drives that. But it has an interesting correlation. So they were looking at precip and looking at thresholds. The red one is the top 5% of the amount of rain in a day. So the rainiest days, the top 5%. Well, that pattern's kind of starting to come out versus everything else. And Mike said, well, what the heck, let's look at, he did a Pineapple Express. So these are a subset of atmospheric rivers. These are atmospheric rivers that originate around Hawaii and have distinct characteristics in terms of the alignment of the atmospheric river hitting California. And now you look at that. And so when we go dry, we're not getting atmospheric rivers. When we get a wet period, we're getting more of them. But again, I said, we don't know what drives this, but we know it's important. Now here's some fun. Now you saw on this chart here, the continents are all black, and that's because this is satellite data, and it works really well as long as you have water underneath. Okay, not really where people live, though. It's kind of important. So we invested some money, and now we have data over land. And what you see here with all these white-ish numbers that if you got close enough, you could see they're really, really small. And this is just after Christmas in 2013. And what we had when it was really dry, this is a 0.5 centimeter of moisture. And that's the amount of water vapor in the atmosphere. If you condensed all of it over that column over Sacramento, the whole column of the atmosphere, squashed out, condensed it, you'd have 0.5 centimeter of water. You think that's dry? Over Yosemite, there was 0.5 millimeter. It's not going to rain when that is what we have over top of us. Now, remember at the end of January and beginning of February, things finally did change. The ridge broke down, came in. These are the numbers. These are now over 3 centimeters, and the magic threshold is 2.5. Once we get above 2.5, we can actually have a decent rainstorm. We now have data, so we're just starting now to compile a record that actually gets to the process rather than just waiting to see what the outcome is, and that's an important piece too. So now we're going to get into what's happening and what's going on with the current drought. Here's time series of the 8-station index again. And again, it has the average that's 50 inches to remind you about variability. Our wettest year in 83 was almost 90 inches. And here's the fun part and what part we're more dealing with now. Back in 1924, only 17 inches fell all season long. In 2 months, on average, in December and January, you would get that. And that whole year, it took the whole year just to get that much. Water year 77 was on pace for that until September came along, got a little wet, and kicked it up above it. But it's right in that same ballpark. So we had 2 years that are kind of like that. But you'll notice here, and this is fun, 9 of 14 years of the 21st century are below average. And we'll see that later on as well and how that plays out. Alrighty, so here's fun. Here's a line chart. It's a little pale. But what you see faintly this big one here, there's 82, 83. Way up here, and here is average. There, and there are the past 3 years. Not quite getting there, but how we got there is quite interesting. So the first time was this one. We started pretty good, and then we went flat, and then it was, New Year's, and they're talking about ice skating on Tenaya Lake. And I got my first question. So, is this what climate change is? And I said, no, this is a dry year. Hang on, we'll see what happens. And sure enough, we got bailed out in March, big March. Almost average snowpack in the north, and that's very important north of Delta. It was only in the north. South folks didn't get that bailout. Anyway, that kind of erased worries. Okay, we're good. It came in March, a little late, but it works. Next year starts, and we're thinking, oh, hey, we're doing great, because in December, and this was about the time I announced that network for observing extreme precip at AGU, and it was just so nice of Mother Nature to give us 3 atmospheric rivers right then. So it rained on 25,000 scientists, just to help drive the point home. Anyway, at that point, we're wetter than the wettest year on record. What could possibly go wrong? Well, there's a little drawback. In that 10-day period, where those rains at the beginning of December, that was a third of the water year precip in 10 days. Right around Christmas, we had another stormy week. That was a third of the Northern Sierra snowpack. Again, we're wetter than the wettest year on record. Things are going great. Unfortunately, for the next 14 months, it went dry. And it didn't just go dry. It went drier than it had been in over 100 years of observations. Well, that's a little disconcerting, because first you're thinking, all right, well, we're good. We can ride this out, we'll get through that year, and we'll get into the next year. The trick is you had all your expectations set here. Mother Nature changes. Mother Nature's no longer contributing base flow or anything else, and you're going to try and operate water systems in the entire absence of Mother Nature supporting you through that period. And it went all the way here. And in that time period, by the time it started raining again, and about this time I ran away to Canada to go look for storms. Funny thing about going storm watching that year, I got up to Vancouver Island and saw a glassy calm Pacific. For what it's worth, it had the locals up there freaked out as well. But anyway, it did rain down here, and though we were drier than the driest year on record. So in a 14-month period, we spanned the entire distribution of our observations. But when we get to here, and we say, wow, it's a record drought. Well, with the water year total, it's only 8th driest. So if you go back and look, and you're just looking at certain perspectives, you're going to miss an awful lot that's going on here. Here's another facet to look at, and this shifts slightly. These are our friends up at Western Region Climate Center. And you'll notice this 3-year period starts July 1st and it's June 30th. That's the Weather Service's version of a water year. And these 7 blocks are the 7 climate divisions of California, and it's for all 7 of them. Again, our wettest year is 81 through 84, and this is 3-year periods. 74 to 77 had been the driest. This green area was the past 3 years. Notice how many times and how far that is under that 74 to 77 line. And yes, we did finish, so here you are. You have a 3-year period that is record dry for the whole state. Alrighty, here's another fun way to look at things. This is snowpack. This is from NASA's Jet Propulsion Lab. This is taking MODIS satellite data and trying to look at snowpack and interpret how much water is there. And this is for May 4th. So this is about a month after peak. This says we're starting to get to the peak runoff season. This is good, and we see lots of blues, and that's about a meter of snow water equivalent. So 39 inches of snow water equivalent everywhere. You see nice, dark, pretty blues, and here's the elevation, so you can see that, boy, yep, that corresponds to those high elevations. And here's the fun part. Next slide is what happened this year. You'll notice there isn't really any snow in the Feather River watershed on May 4th. So getting to peak runoff, what do you mean peak runoff? You're done. There's what little you might have had, just little bits and pieces. And that one storm that came through, hit the American River watershed, there's the remnants of it in that one little spot. And you'll notice with atmospheric rivers, they're not very wide. But you see the high elevations, it's just not, there's a little bit there, but not a whole lot, and certainly not what we want for May 4th. And that was our largest reservoir that Mother Nature provides. Here's what we provide. Now this is probably a sign that the drought got interesting. This is a friend from Washington, D.C. who works with the USDA. He went through a bunch of text files within CDEC, which is our data exchange center. And he compiled data of our 154 reservoir reports. And he pieced all that data together month by month. And he came up with the last 5 years, came up with average, and he came up with 77 to look at how the drought played out in terms of the reservoir reports. I really appreciate him taking all the time to do that. Anyway, you see here up in 2011, we were fantastic. Things were looking awesome. Here, 2012, we started off great, but then things really fell apart. And 2013 and 2014, and he said, well, hey, look, you're doing great. You're better than 77. But it was fun talking with the water managers who said, yeah, there's more water there, but there are also more demands on it, and the amount of water actually available is less. So that water, even though it's there, is already spoken for. It has its jobs that it has to do. And that's really an interesting concept to try and convey to the folks in the Drought Monitor who might just look at numbers and think, well, it's one way, and you have to give a little more perspective because there's more to it than just the number itself. All righty. Oh, don't fail me now. There we go. All right, another one that we use on CDEC. This is to give you a sense of where we were when we started the water year. And you see the red lines, that's where we're supposed to be. Where you see the blue is where we were. So we had a fantastic December, right? And things were really good. Well, here's where we are, and you still see the red lines are way above, and that's where things hit. If you look at things down here in the San Joaquin, things didn't get better, and in the case on the Merced River, it actually got worse. All righty, so signs of change. What are we looking at now that doesn't look like how it did? And by the way, it's not going to keep looking like this. It's going to continue to change. Here's our expectations. This is a small list of things that we think are going to happen. Warmer temperatures, smaller snowpack, more rain, less snow, earlier snowmelt, more variability, more extremes. Well, you know, we say it's going to happen, it's going to happen. Well, guess what? We might be seeing some of these already. Here's the 21st century. So this was Aid Station Index. Remember I showed you a nice one plot. Those are the blue ones were the period of record. 71 to 2000, the last kind of 30-year period of the 20th century are the red bars, and you'll see some change. They're a little higher, and if you look at the numbers up there, you see period of record average is 50. That last 30 years, we were at 53. We had some bonus water being delivered. Now, if you look at the 21st century, you see we're down to 49. Okay, so Mother Nature's now kind of keeping some back. And whoops. Oh, hold on there. Let's not get too excited. You see that fantastic bar in December that makes you think, wow, Decembers are super wet. Awesome. Great. I want to remind you that 2012 was the third driest in almost 100 years of record with 1/3 of an inch, and 2014 there with 0.8 of an inch was fourth driest. So think about that those two are going into that average that still gets to 12. When the switch is on, it's on, and when it's off, it's off. And averaging it together doesn't mean a whole lot. Sacramento River runoff, we see a similar story, but here's something that might be a little disturbing, is that winter runoff isn't there, and it's not there to the tune of almost 2 million acre-feet. So that makes things kind of entertaining. to try and manage water through that. Now we notice that these are down a little, not as much as these. I wonder if storms are missing. Okay, so here the 2 actually belongs in that funny shape that's the Sacramento River watershed. So Climate Division 2 for NCDC's records is the same as the Sacramento River watershed, which works out nicely. So I can use their data. And this is calendar year data now, so we have to switch our perspective a little bit again. This is calendar year data of precipitation, accumulation, and temperature. The yellow triangle is the period of record of over 100 years record. It goes back to 1895. The diamonds are all 20th century values, and the black squares are 21st century values. Now something ought to jump off the page at you really quickly. How many black squares are below the period of record average? Answer is none of them. We're not in this part of the distribution anymore. We're already on the move. And this weird year out here, 1934, that's just so far off the charts, now has a lot of friends. And we say, yeah, 2013 was drier than 76. Yes, it was, but it was also 2 degrees warmer. So it's not the same drought anymore. And it's not going to be, because they were not going to keep sampling here. Expectations are this is going to move another 3 to 4 degrees that way. Here's, real quick, we'll get this so I can get finished up on time. April through July runoff is on the bottom. Water year runoff for the Sacramento Rivers on the y-axis. Again, period of records, the nice triangle. Diamonds are 20th century values. Green squares this time are 21st. And if you count them, 9 of the 14 are down in the bottom corner here. 5 of the lowest 20 April through July flows are since 2001. Just in case you thought, oh, hey, we saw those bars on the Sacramento River flow and it wasn't too bad, was it? So things are getting interesting. We better figure out a way to try and keep track of it. This is the first attempt at the Western Region Climate Center. It's called the California Climate Tracker. It takes the Weather Service Cooperative Observer data of rainfall and temperature. They came up with their own regions, and with each of those you can break down the record from 1895 to present, and this is for precipitation for the state. This is the regions, this is the past water year. You'll see the South Coast where we have quite a few people, and this region where we do quite a bit of ag. That was the driest water year they had ever seen. Temperature-wise, everywhere you see red was a record, and that's the water year. Unfortunately, we'll be wrapping up in 2 more slides. Like I said, I told Jeff, I'm going 20 minutes and 30 seconds, just for him. Anyway, so what you see is everywhere you see there is a record, and that's going to keep happening. That's not just an aberration anymore. Alrighty, so some final thoughts here to wrap up. Current drought and 21st century droughts have shown record-setting characteristics, and they are warmer than their 20th century counterparts. Atmospheric rivers, those are the key. When they're there, we have water. When they're not, we don't. What that means then, instead of thinking about how much rain falls in a year, you got to start thinking about opportunities to have these storms come and get us. Our best opportunities are in those 3 months where we, on average, get half our annual precip. Now, just because things are changing doesn't mean you can abandon the past. There's information in there, and you really need to pay attention to it. And paying attention to what's in the historical record, including paleo reconstructions, the trick is increasing your understanding of causal mechanisms and process, and how the watershed condition response happens under differing conditions. It's there, we just have to figure it out. And finally, this is the big one, averages aren't so useful anymore. You really need to start thinking about variability and thinking about process to really understand how things are going to play out from here on out. All right, there we are.